We're going to work on identifying the intermolecular forces between atoms, ions, and molecules. There are 4 types of intermolecular forces. Dispersion forces, or London dispersion forces, occur with all substances, whether the molecule is polar or nonpolar. And dispersion forces are the weakest of the 4 intermolecular forces. Dipole-dipole forces are present only in polar molecules. Hydrogen bonding forces are present when one molecule has a hydrogen bonded to a nitrogen, oxygen, or fluorine, and the other molecule has a lone pair of electrons on a nitrogen or oxygen or fluorine. And hydrogen bonding forces are strong forces. Ion dipole forces are present in ions and polar molecules, and ion dipole forces are the strongest of all of the intermolecular forces. When we are trying to determine what type of forces are present in molecules, we are going to first examine whether the molecule is polar or nonpolar. And for us to determine if the molecule is polar or nonpolar, we have to have the geometric shape in order for us to figure out the polarity. Intermolecular forces are also related to physical properties. Stronger intermolecular forces result in higher melting point, higher boiling point, larger viscosity, and lower vapor pressure. Let's take a look at an example. Identify all of the intermolecular forces present and identify the predominant force in each molecule. F2 has this shape. So F2 is a linear covalent diatomic molecule, and it is nonpolar. So the only force that F2 exhibits is dispersion forces. And dispersion forces is going to be the predominant force for F2. ClF looks like this. It is a linear molecule, but ClF has a dipole. So this molecule is polar. So all of the forces that are present in this molecule is going to be dispersion forces, because dispersion forces are present in all molecules. And because this is a polar molecule, it also has dipole-dipole forces. And the predominant force for ClF is going to be dipole-dipole. NF3 has this shape. So this is a trigonopyramidal, and this shape means that it has polarity. So this is a polar molecule. So all of the forces that are involved in this molecule is dispersion forces, because all molecules have dispersion forces. This is a polar molecule, so it also has dipole-dipole. Between these two forces, dipole-dipole is the predominant force. NH3 has a similar shape. So NH3 is a polar molecule, so it has dispersion forces. And it's a polar molecule, so it has dipole-dipole forces. And let's go ahead and examine this molecule a little bit more. It has a hydrogen that's bonded to a nitrogen or an oxygen or a fluorine, and this NH3 can form an attraction between another NH3 molecule, and this molecule has a lone pair of electrons on nitrogen. So this type of force is called hydrogen bonding forces. Between these 3 forces, hydrogen bonding is going to be the predominant force. Nickel 2 bromide dissolved in hydrochloric acid. You want to know that the hydrochloric acid, you can assume that it is an aqueous solution. So let's go ahead and examine this. Nickel 2 bromide is an ionic compound. When you dissolve it, it's going to form Ni2 plus and Br minus. And hydrochloric acid looks like this, which is a polar molecule. So let's discuss its forces. So if ionic compound gets dissociated, it gets dissociated into ions. An ion in a polar molecule, we have some forces here. So all of the forces is dispersion forces, because all molecules have dispersion forces. And we have some polarity, so we can say there's a dipole-dipole force being present here. And we want to not forget that hydrochloric acid is an aqueous solution. We can assume that. That means it's dissolved in water. Water has hydrogen bonding in it. And the nickel 2 plus dissolved in hydrochloric acid means that we have ions in polar, which means ion dipole forces. So in this situation, we have all four forces, and the predominant force is going to be the ion dipole force. Let's take a look at another example. Arrange the following compounds in order of increasing boiling points. So when we are talking about physical properties like boiling point, I want to remember that the stronger the intermolecular force is, the higher the boiling point is. So I'm going to examine all of these three molecules, and all of these three molecules are made up of 5 carbons and 12 hydrogens, but they're arranged differently. So for this one, for pentane, we have dispersion forces. It's not polar. Neopentane, again, dispersion forces is the dominant force here. It's not polar. Isopentane, again, non-polar, so only dispersion forces. So all three molecules are tied up in the type of intermolecular forces. So the next thing I want to look at is maybe the way they're branched out. Increased branching leads to a lower IMF, and a lower IMF leads to a lower boiling point. So let's take a look at all three molecules. And increased branching means it has the lowest melting point. So the one that has the increased branching is neopentane. So that should have the lowest boiling point. Then isopentane. Then pentane. Pentane is a linear molecule, and so it has the highest boiling point. Neopentane has the most branching, so it has the lowest boiling point. Let's take a look at another example. It says here, arrange the following compounds in order of increasing melting points. So let's take a look at these three different molecules. CH3Cl looks like this. And the dominant force in CH3Cl is going to be dipole because it is polar. CH3OH looks like this. And sure, it has dispersion forces, it's a polar molecule, it has dipole, but it also has the hydrogen bonded to an oxygen, a nitrogen, or a fluorine, and the oxygen has lone pairs on it. So the dominant force here is going to be a hydrogen bonding. CH4 looks like this. And this is a nonpolar molecule, so the dominant force here is dispersion forces. I also want to remember the stronger the intermolecular force is, the higher the melting point is. So the molecule that has the highest melting point is going to be the one that has the strongest force. The one that has the lowest melting point is going to be the one that has the weaker force. So CH4 is going to have a lower melting point than CH3Cl, which is lower than CH3OH. So methanol has the highest melting point, and methane has the lowest melting point. Good luck and keep practicing.